This question is another rotational motion question, and we're basically being asked to make predictions and write equations about what will happen in this situation, where we have two identical spring scales attached to two pulleys, each with equal radii. So the radii are equal. And this one we are told is that the mass is centered around the outer edge, where the mass is throughout. And so we should remember that the moment of inertia, the rotational inertia, is proportional to mr squared. So as the mass moves outward, I increases. So in other words, pulley B has more rotational inertia than A. And so that's really the main difference between those two. So just quickly going through the verbiage they've given us here. Two identical spring scales, which we noted. They're attached to a cord wrapped around the pulley. The other thing that we might note here is that the point of attachment with the weight is perpendicular. And so if we're thinking about torque with RF sine theta, well, that theta is 90 degrees. It's at the lever arm is at 90 degrees to the radius. So that's just something to be aware of there, that point of contact. Wrapped around a pulley. Two pulleys of identical mass, so the masses are equal and radii are equal. However, A is a solid disk, so the mass is distributed throughout. The mass is distributed throughout pulley A, and it's concentrated on the outside of pulley B. Both pulleys can rotate with negligible friction. The negligible friction is important, like so. So they're initially at rest. So that means that their omega naught is 0. They're pulled with the same constant force. Okay, so they're pulled with the same force. So the forces are equal. Both rotate. Predict which of the pulleys will complete one revolution first. Okay, so when we look at this one revolution, we're going to start, say, with this particular place here, and it will go all the way around, like so. Well, what is rotational inertia but an object's ability to resist a change in rotational motion? To resist a change in rotational motion. So this one will resist more, which means it will travel on average more slowly. It will experience a lower alpha rotational acceleration. So pulley A will complete it first. And our reason for that is pulley B has a greater I, which means its alpha will be less. This results in a lower average omega, and therefore more time to complete one cycle. And that's it. You may notice with this question it says without writing any equations or provide reasoning in your selection. Notice all of this reasoning I did with the formulas up here, the semi-quantitative reasoning and such. I didn't include any of that in my answer because they're specifically asking not to do that. I can list the quantities that I'm talking about and in words talk about relationships, but I don't want to include the formulas there.